Now today we are going to start to new module optical resonator and laser cavity modes. In this module we discuss about the various types of optical resonator, how to work it, and different laser cavities of modes. So now today we are start firstly introduction about that is optical resonator. So first is a introduction. So in this in this optical resonator we get the electron oscillator, the amplifier tuned a specific frequency is provide the positive feedback. So see in figure, this is the amplifier, this is a feedback. So this is the input waves, and it is completed in the form of due to feedback amplifier we get the output formation of waves. So in this way we get the feedback amplifier using we get the optical resonator frequency. So the oscillator when also switched on, then any noise signal can be appropriate. The frequency appearing in the input form then amplified can be the stable output is quickly reached. Any oscillator switch on, so the signal appropriate frequency the appearing in that input amplified circuit, so we get the stable formation of output. Input produces by amplifier due to feedback in the form of output waves. So at frequencies at high frequency, waves cannot be defined in particular wires. So at that microwave frequency, the cavity for example, various types of cavities can be used in this way. So cavities can be completely fulfill in that metal box, and that closed cavity is an light frequency formation. So it can be the wavelength is few 0.5 approximately millimeter form. And so in this cavity modes, the we get the lasers can be active medium, and in the form of pair formation we get. So that emitted the photon is spontaneously emitted along that optic axis. So the laser can be introduced in the form of rod or a tube, and that takes place the stimulated emission of radiation photons can be reflected in the form of mirror. In this cavities mode we get find out the microwave frequencies. So next topic is action of optical resonator. So in this resonator we get the successive stages of the action of an optical resonator can be dissipated in the active center medium. So in that ground state, that the pumping mechanism can be produces the medium can be in the formation of state of population inversion. So in this way the large number of excited atoms decay spontaneous phenomena generated, and they get the photons emits in various directions. So large number of excited state atom decay spontaneously, they emits the photon in all directions. So the spontaneous of photon can trigger the many stimulated transitions along the direction of its propagation. When spontaneous phenomena generated, the transition state will be reached, and spontaneous photons emitted in various different formation of form of directions, and they stimulated photons travel in identical formation of direction, and they travels in the form of various directions. So initially spontaneous photons emitted in different directions, and stimulated photons also travels in the in the different directions. We get the net effect of coherent light. It produces a specific directions. So in this way, we get the spontaneous due to spontaneous phenomena, the photons emitted in the form of various directions. In the presence of end of mirrors, specific directions is imposed on that photons. Photons can be specific form of directions will be we get form. So photons propagation along the optic axis, the pair of mirror photons emitted in other direction that pass out the sides of resonator, and that will be lost. When photons in the optics axis propagating in that optic axis, we get the pair of mirror photons is emitted in the in other opposite formation of directions, so that can be resonated, pass out, and his will be lost. So that will be the see in the diagram how can be lasing medium in ground state. In that fully reflective mirror nuclei, we get can be this is the fully reflected mirror nuclei, and that will be the lasing medium. And second thing is a partly reflective mirror nuclei. In this way, the photon majority of photons traveling along the various reflected back of reaching that end of mirror nuclei. They propagating towards the opposite mirror, and their way will be stimulated, can be more and more can be atoms will be towards propagated towards the opposite formation of nuclei. So in this way, the stimulated way, more and more atoms can be built their individual in the form of the majority of build up the strength. So see in that figure, we get the majority formation of mirror nuclei, and that stimulated more and more atoms we get the form. So in this way, mirror nuclei provide the positive feedback. So that case will be medium can be stimulated emission, and that laser operates and is in the form of oscillator. The photons can be that opposite mirror and reflected in the form of particular medium. See in that figure. See, second is a population inversion processing thing. The atoms that will be in excited state, and these atoms will be in present in the ground state. Due to spontaneous emission of phenomena, we get the population inversion state. So third is spontaneous emission and stimulated emissions can be occur. The atoms in the form of one or two more atoms formatted in the form of stimulated emission of process. So that will be the atoms in the ground state and excited state combined together form in that way. So we get the spontaneous emission, start of stimulated formation of emission. So next is stimulated emission build up the various type of nuclei. that stimulated emission takes place, one or more nuclei, one atoms will be formed, we get in that figure. So fifth is a coherent light with all waves linked in that phase. We get the mirror nuclei from the various types of atoms is using that coherent light of sources in all linked of phase. We get the by passing the laser beam, we get the various formation of coherent sources travel, and in that phase we get the various types of laser beams of nuclei form. So in this way we get how to resonator can be action in that optical resonator. So thank you.